Alright, this video is going to cover the 3.2 set. And in this, it says solve each of the quadratic equations using the appropriate method. Give a precise answer rather than an approximation. So it wants a precise answer. Well, the focus is going to be on how do we know how to solve these. So far, we know for solving we can take something from vertex form and we can do inverse operations. We can take something from factored form, or that's not quite in, standard form, excuse me, and we can factor it and set each of those factors equal to 0 and solve. Or the other day, we introduced the idea of the quadratic formula, which again is the end-all be-all. Remember that formula, x is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. That comes from the process of completing the square. We could do that as well, right? But the idea is to look at a problem and go, how do I know what is the best method? What is the easiest to do that? Well, it takes practice. I'm going to look at question number 5, and let's just assume we factor. All right? Well, my factors of 7, because you multiply a times c, right? Well, what are my factors of 7? 7, I need factors of 7 that give me 5. Well, there are none. So, for this one, I'm going to use the quadratic formula. I have to, because I can't factor it. How about 6? And if you're following along, factors of 16, we're going to do the same thing. The factors of 16 are 1 and 16, 2 and 8, 4 and 4, 5 no, 6 no, 7 no, 8 yes, 9 no, 10 no. Which factors of 16 will give me a positive 15? I could make this work. So I could factor this. If I can, factoring is easy. Well, gee, a is 1, so I'm going to have x plus 16 and x minus 1. Set those factors equal to 0. So x is equal to negative 16 or positive 1. See how quickly I did that? I couldn't do that up here. No, I had to plug it into that monstrosity of a form. So it's beneficial to determine how can I factor this. Are there factors of 35 that'll give me 2? Are there factors of negative 1 that'll give me 9? No. So I'm going to have to quadratic formula. Now, what about when we get into some other ones, such as like 9, okay, and 12? 9 and 12. Well, I've got to multiply a times c, right? Negative 14. List your factors of 14. 1 and 14. 2 and 7. Are there factors of 14 that will give you 6? Same philosophy applies. The thing that changes is a is greater than. And then when we get to 12, look at what you'd have to do. 3 times 14. I don't want to do that. I don't want to list 3 times 14 because I know it's going to be a big number. 4 times 3 is 12. Carry the 1, 3, 4. That's 42, which isn't too bad. But still, I'm listing factors of 42 to give me 6, and I got to do a bunch of stuff. Can I? Maybe I just don't even mess with that right away, and I skip and I go straight to the quadratic formula. Okay? So where you identify A, B, and C, A is negative 3, B is negative 6, C is 14, and I plug them into the quadratic formula. All right? So again, it's just identifying which ones you want to solve using the quadratic formula and which ones you don't. So let's solve all these. All right, and we're going to pick the appropriate method and we're going to solve them all. There's not too many. And then we want to answer the question at the end. Okay, which of the quadratic equations have been solved by factoring? Okay, so list which ones you've solved by factoring. So you might write that over here. Okay, and write the numbers of them. All right, which should be more efficiently by using the quadratic formula. How can you tell from the solutions? The solutions should be able to tell you which ones, and that's the idea of this lesson.